Hey folks, how's it going? So in this video we're going to be looking at this question. We have a parabola y equals x squared and we have a point P on it. The coordinates for that, we've labeled as x comma x squared. And then we have a point B on the x-axis, right, 1 comma 0. And we have a point A on the y-axis, 0 comma 1, excuse me. And they both join with P using these line segments. Right, so what we want to do is we want a couple of things from this figure, right? The first thing we want is the area of the triangle PBO. Okay, so the triangle that we're talking about is this one, P, B, and O, the origin, right? So it's this kind of slanting triangle. Okay, so recall the formula for the area of a triangle, right? And what's the formula for that? It's a half times base times height, right? So for the triangle PBO, right, what's the height? Say we drop a perpendicular onto the x-axis from the point P, right? I'm going to mark that as a right angle. Okay, so what's the height of this point? If you take a look at this this portion, right, the y-coordinate of point P is just the height of this right angle triangle, right? I'm sorry, of this line segment. So that's just x squared, right? So, and the base for the triangle PBO is this, right? The line segment BO. Okay? And as you see from the point B, this is just unit length, 1. Right? So the area of this triangle PBO is just half times the base, which is 1, times the height, which is x squared, right? Which is just what? X squared over 2. Make sense? Alright. Now the other thing that we want from it, which is the area of this triangle. PA. Sorry, I meant to write A over there. PAO. Okay. So that is this triangle. PAO, right? Once again, we're going to use the similar method. We're going to drop a perpendicular from point P, but this time onto the y-axis, right? And if you look at this distance, it's just going to be the x-coordinate of the point P, right? So just x. Okay? And the base for this triangle, PAO, is going to be this part, right? So that's another unit length segment, right? Because that's just the y-coordinate of point A. Right? So the area of triangle PAO is going to be half times its base, which is 1, times its height, right? Which is just x in this case. That is x over 2. Alright? So we have two results, x over 2, and we have x squared over 2 for the other one. Right, so keep those in mind. I'm going to erase this board. Alright, so as a function of x, right, the area of triangle PBO, right, is x squared over 2. The area of triangle PAO equals x over 2, right? And we need, the third thing we want is this function, a of x, which is just the ratio of these two, right? So it's just x squared over 2 over x over 2, which is just x, right? Function a of x, okay? Alright, so the final thing that the question asks us to do is compute the limit as x approaches 0 from the positive direction a of x. Okay, that's not a b, that's just a 0. Okay, so it's pretty straightforward because this just equals limit as x goes to 0 from the positive direction of x, right, which is actually just 0, right, because you're going along the x-axis and you're going towards the origin from the positive x direction, right? 0 is exactly where you're going to end up. Okay, that's pretty much this question. There is a table here, which is asking you to plug in different values of x into into the areas for this triangle and even a of x, but it's pretty manual. I'll let you do that. All right, thank you.